Firstly, the objective of this experiment is to determine the coefficient of static friction of different surfaces. Furthermore, force and velocity are vector quantities that have both magnitude and direction. Velocity is the speed in a specific direction with which a given object travels. Force exists when the object accelerates or undergoes a change in its velocity. A body at rest or in equilibrium exhibits resultant force, or the sum of all forces acting on the body is zero. Gravity is an attractive force that exists between two masses. The magnitude of force depends on the magnitude of the masses. The gravitational force that acts on an object on Earth is approximates as force equal to mass over gravitational acceleration. M is the mass of the object, and g is the gravitational acceleration. The magnitude of the gravitational force exerted on an object is referred to as its normal weight. Normal weight is a contact force that acts in the normal direction or perpendicular to the contact surface between two objects. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of frictions, which is static and kinetic friction. Static friction is the friction that acts on an object that is at rest. Meanwhile, kinetic friction is the force that must be overcome to move a static object. The maximum value of static frictional force is given by force max equal to normal. Um, S is the coefficient of static friction and N is the normal force. Kinetic friction is the friction that acts on a moving object, and the kinetic frictional force is given by K is the coefficient of kinetic friction and N is the normal force.
So for this experiment, the apparatus needed is wooden block, 50-gram masses, 10 Newton spring scale, string, and tabletop. Here is the procedure. The mass of the wooden block was measured and was recorded. The apparatus was set up as shown in figure 2. This on the picture shown the apparatus setup. Next, the tabletop was made sure stable and horizontal to the ground. The spring scale and the wooden block were attached to a string. Place them horizontally on the tabletop. The rubber side of the block was made sure to face downward. A mass of 50 grams was placed on the wooden block. The spring was pulled slowly. Once the block started to move, the spring scale's reading was recorded. Step 4 until 5 was repeated for 3 trials. Another 50-gram mass was added to the wooden block, and step 5 to 6 were repeated. The steps were repeated until the total of 500 grams was on the wooden block. The last one, step 1 until 8, were repeated, and the rubber side of the block was made sure to face upward. All of the data in table 5.2 was calculated.
Here are the results that we obtained from the experiment.
The first analysis in this experiment is draw and label the free body diagram of the wooden block. On the left side is the free body diagram for the rubber surface toward the floor, and on the right side is the free body diagram for the non-rubber surface toward the floor. On to the second analysis, which is plot graph of static friction against normal force for the rubber surface and non-rubber surface. Next, analysis number 3. Use the gradient obtained from the graph to calculate the coefficient of static friction for each surface. Based on the calculation that we calculate, The coefficient for the rubber surface is 0.88 plus minus 0.33, and the coefficient for the non-rubber surface is 0.46 plus minus 0.14. Lastly, the analysis number 4, compare and discuss the coefficient of static friction that obtained. The value coefficient of static friction obtained from the experiment for the rubber surface is 0.88. Meanwhile, for the non-rubber surface is 0.46. Therefore, the coefficient of static friction for the rubber surface is higher than the non-rubber surface by difference of 0.42. The coefficient of static friction depends on the material involved and the roughness of the surface. A rough surface will produce more frictional force when come into contact with the floor. This implies that the rubber surface has stronger resistance to motion and need a greater force to slide compared to the non-rubber surface when both are in contact with the floor.
Anti-lock brakes operate by detecting when the wheels are about to lock. Optimum pressure is necessary to rapidly decrease and increase pressure multiple times per second. This enables the wheels to keep moving as the car decelerates, instead of locking up. If the wheels lock up, kinetic friction will occur, thus the car will be stationary. However, given that the static friction is greater, it will affect the anti-lock brake pump the brakes so that the tires will experience static friction, not kinetic friction. This will cause the car to decelerate faster and reduce the stopping distance. Our experiment concluded that the block with the rubber surface has the greater coefficient of static friction than non-rubber surface. Yes, the experiment support our hypothesis. This is because the rougher surface, such as rubber or concrete surface, tend to have a higher coefficient of static friction. The coefficient of static friction is the maximum ratio of applied force to normal force with no motion. Surface materials determine the coefficient of static friction because different materials have different coefficient of friction. The mass will begin to slide with a stop and go motion. This is because there is a force that opposes the motion, such as friction, to overcome the force that drives the motion. Friction force is the force generated from two different surfaces that slide against each other. Thus, the velocity decreases.
Friction is a force that resists motion when the surface of an object comes in contact with another surface. Therefore, the frictional force is a retarding force that resists the motion of an object that is in contact with the surface. Frictional depends on the material of both object surface and weight. This can be proved by observing the graph of static friction force against the normal force for the rubber surface and non-rubber surface. From the analysis, the coefficient of the rubber surface is greater than the non-rubber surface. This is because different materials have different coefficient of friction. However, there may be a few errors due to inconsistent force in this experiment when pulling the block. It is the best when one person pulls the block 3 trials. Next, there are possibilities of experimental error occurring in the experiment. First is the parallax error. This happens due to mistake in the reading scale. The best way to minimize the parallax error is by taking a set of readings by different observed. Lastly, to minimize the random error by averaging a sufficiently large amount of result.
In conclusion, the coefficient of static friction of different surfaces was able to determine through the experiment. Wooden log, 50-gram masses, 10 and spring scale, string and tabletop were the apparatus used in this experiment. The wooden block mass was measured by weighting it on a weighting scale. 3 trials were done on both surfaces of the wooden block to detect the average static friction force. From the experiment, the free body diagram was detected and a graph was done to show a relation of static friction force against the normal force of the rubber surface and non-rubber surface. Lastly,
Lastly, the coefficient of static friction for each surface was obtained, showing that the objective of the experiment was achieved.